Hi, this is Bentley's mom again, and we're going to go over Chapter 10, Lesson 4. It's on page 774 through 775. So what this is the surface area of a triangular prism. So we did volume of both the triangular prism and the rectangular prism, and then last week we did surface area of a rectangular prism. So I'm just going to review that real quick. So what this surface area is all of the sides. So for this box right here, this is a rectangular prism. We had to say like how much cardboard, would we need to make this? So you have to take the area of the front and the back, the top and the bottom, and then the two sides, and then add those all together. So surface area takes a while because you have to find all the things and then add them up together. So with the triangular prism, I don't have an example of one. But if you look at the pictures, a triangular prism, I'm on page 774, example 1, kind of looks like a tent, like this. And I'm not really good at drawing these. Okay, but it looks like this. Okay, and this is a triangular prism. Okay, so what we're going to do here, so I kind of picture like a tent, is if you look at the shape, there's 2 triangles, and then there's 3 rectangles. So on all of the triangular prisms, that's what you're going to have. You're going to have 2 triangles, and those triangles are always going to be congruent, or the same measure. And then you're going to have 3 rectangles. Now on the 3 rectangles, if it's an equilateral triangle, which means all 3 sides are the same, these 3 rectangles are going to be the same. But that's not always the case. Sometimes 2 are the same if it's an isosceles triangle, sometimes all 3 are the same, and sometimes all 3 of them are different. So you have to be really careful with that. So the 2 triangles, what we're going to do is find the area of that. We know the area of a triangle is 1/2 base times height, okay? And then you can either write it twice or times it by 2. What I do is I like to draw all the shapes out like this so that I don't forget one or accidentally count one twice. So I'm going to do the 2 triangles first. And on example 1, you have to do the base times the height. So you have 1/2 times the base, okay, which is this right here, which looks like 1, and then times the height, which remember the height has to meet the base at a 90 degree. So it's not this length right here. It's the one that they have to meet, and you'll see that little box at 90 degrees. So that would be, it's drawn in on the side. You can see a little arrow, and it says 0.9. So this is 0.9. Okay, so you could do 1/2, put in your calculator, 0.5 times 1 times 0.9, and hit enter, and you get 0.45. Okay, and then I circle that so it doesn't get lost in all the mess. And then the triangle in the back is exactly the same. So we're going to do the same thing, which is just 0.45. So you can either times that by 2, or you can just add it again. Okay, so those are the 2 triangles. Now I'm going to do the rectangles. The first one I'm going to do is the bottom one, okay, which is this one right here. So I'm going to look at the measurements of that, and it is going to be base times height, which is 1 times 2, and I get 2. And then the side is also 1 times 2, which I get 2. And then the other side is 1 times 2, which is 2. So this happens to be an equilateral triangle. Again, that's not always the case. These aren't always the same, so you can't just multiply it by 3. In this case you could, but that's not always the case. So now what I'm going to do with all these circles, because I have a triangle, a rectangle, and a rectangle on the bottom, we're going to add all these together. Again, so you can put that in your calculator, 0.45 plus 0.45 plus 2 plus 2 plus 2, or you can do it in your head, and you get 6.9. And the unit is centimeters, and because it's area, it's always going to be units squared. Okay, so that's example 1. Now right underneath it, there's a practice problem, and you can hit pause if you want and try it, and then I'll do it right now. So I'm on letter A. So we have the 2 triangles, okay, and then we're going to have 3 rectangles. Okay, so my first triangle, if you look at it, the triangles are going to be the same. It's 1/2 base times height, so 0.5 times 6 times 5.2. Okay, and again, the height is where it meets the base at a 90 degree angle. So this part was 6, and then this part was 5.2. Okay, and those are the two that you use. So you put this in your calculator, and we get 15.6. So if this triangle is 15.6, this one's also going to be 15.6. So again, you can either write it twice or times it by 2, either one. Okay, now the first rectangle I'm going to do, and I like to write them down in case they're different. So I'm going to look at the bottom rectangle, and it's going to be 6 times 6, and that gives me 36. Okay, and then I have two sides on this one, a side and the other side. And one side is 6 times 7, which is 42. And then the other side is the same. It's also 6 times 7. And that's 42. So this was an isosceles triangle. Two of the sides were the same. Again, sometimes all three sides can be different, so you have to look really carefully at the problem. Then we're going to add all of these circled numbers up, because surface area is the area of all of the surfaces together. So we're going to add that up, and we get 151.2, and the unit is centimeters, so it's going to be centimeters squared. Okay, and then what I do is I box my final answer. So I circle my answers as I go, the ones that we have to add up, and then I box my final one, and that helps me keep all the work together, because it is going to be kind of messy. It's a lot of work. Okay, so turn the page. I'm on example 2 on page 775. Okay, so we have two triangles. Looks like this. Okay, and again, I draw them like that, and then we're gonna have three rectangles. Okay, and so for this one, it's shaped a little bit different. I'm gonna call this one the bottom, and then this one the top. That's kind of the sloped face that comes down, and then the back side, that's the smaller one, we'll call that the side. And you can call them whatever you want to, as long as you know which rectangle you're looking at. Okay, so the first one, we look at the triangle. The two that meet at 90-degree angle are 8 and 15. So I'm going to have 1/2 times 8 times 15. So 1/2 of 8 is 4, and 4 times 15 is 60. And if this one's 60, this triangle is going to be 60. Okay, and then the bottom one is going to be 15 times 20, because this is 15 and this is 20. So we're going to do length times width. And 15 times 20 gives me 300. I'm going to circle that. And then the top part is the one that slopes down. And that one is 17 times 20. And we get 340. Okay, and then the side, which is the smaller one in the back, is 8 times 20. And so we're going to do 8 times 20, which is 160. Okay, so these are all the areas, and then because it's surface area of the entire prism, we're going to have to add all of those up. So I'm going to add all these together, and I get 920, and it's in meters, so squared meters. Okay? All right, turn the page. Last example. Okay, this is on page 776, example 3. So this looks like a little different shape. So I still have the two triangles. Okay, and then you're still going to have the three rectangles. Okay, so the first triangle, so we look at that. We're going to do 1/2, the base and the height. Remember, the base and height have to meet at 90 degrees. So it's going to be 7 times 12. And 1/2 of 12 is 6, and 6 times 7 is 42. So I didn't have to put that one in my calculator. That one you should be able to do in your head. And we have another one, so we have 42 and 42. And then you can write kind of whichever one you want. The back part of it, the back rectangle is 12.5 times 1. That gives me 12.5. And then we have a side, which is 7 times 1, which is 7. And then we have the front part, which is also 12.5 times 1, and that gives me 12.5. Okay, and then what are we going to do with all these three areas? We are going to add them together to get the total surface area, and we get 116, and the unit is inches, so it's inches squared. Okay, and that's it for the lesson.